So in this video, what we're going to do is we're going to look at the key principles behind finding the dihedral angle using the point view method. So prior to doing this in the lesson, students will have gone over the key principles of the square-based pyramid, the one that they'll actually be working with their problem statement. So they'll have their resource made, and the key principles we'll be discussing, the surface area, the slant length, the volume, the sides, just so students are familiar with the shape that they're going to be working with in the problem statement. Now, when we're doing the principles of actually finding the dihedral angle, I think it'd be very helpful to use a different shape, just so it's not rote learning, done in class and then straight to the problem statement. If they're using a different shape, they'll pay more attention to the principles so they can apply the principles to another shape as well. So in the example we'll be doing in the lesson is the students will actually have made a model themselves and colour in the shape using the same colours just to make it easier for themselves. So what are we actually trying to do? We're trying to find this line here. So this angle, sorry. So I've annotated it as point AB in elevation there. And it's the line of intersection between these two planes here. Now students can annotate that as well if they want to put side 1, 2, side P or Q, whichever they want to do. So the next step they're going to be doing is they're going to be finding the true length of AB. So how are they doing that? They're going to project an auxiliary view perpendicular to AB in plan. And once they have that when they're doing that, which would be very helpful for them, is they can put their shape down on top of it, get down side of the desk and take a look in and actually visualize it themselves, so they're not just using their mind's eye throughout the whole process. Having a 3D representation would be extremely helpful for the students. And then once they project the view from the plan, they will have the heights here equal to that in elevation. But this line here is what's important. So this is the true length of line AB. We have it here, okay? Students will then be able to bring this true length found in the second step there and extend it on further, okay? Then what they'll do is they'll draw their x2, y2. What I'll do is I'll annotate it there. So their x2, x2, y2, perpendicular to the line of sight. So once again, they can move their shape around as they view it, and then looking on along here, what angle are they actually looking at? Well, it's right there for them. They can see it. So it's very handy just so they can get a full understanding of what are they actually looking at. Once they've drawn this x2, y2 perpendicular to the line of sight that they use with the model as well, they can bring, being a second auxiliary plan, they know well that the distances taken are from x1, y1 back to the plan. So these are principles that are going to come up that they've already come across, but are necessary to solve the problem. And what they're left with then is they have the line of intersection as a point, which is the key principle to actually get the dihedral angle. The plane then appears as lines, as you can see there, and our dihedral angle is found here. So what exactly is this? This is an edge view of plane P and Q. So this is plane P here. If we identify that as P, sorry, wrong marker. There's P and Q. So what we have here is plane P and plane Q. So students, once again, if they want to annotate it on their model as well, make it much easier for them to actually understand the principles of finding it using the point view method. So that is the video complete on that.